in my new lecture, we will discuss about some important problems on electrostatics. Myself, Dr. Sayanti Chatterjee, the Associate Professor of EEE Department of IARE College, Hyderabad. So my first question is, if there is a charge Q2 whose value is 121 into 10 to the power minus 9 Coulomb is located in vacuum P2 value is given, find the force Q2 on Q100 microcoulomb at P1. So what is the steps? Step 1 is the first we will write the position vector of the 2 points P and Q. How to write the position vector? For this, the position vector is 0.03 AX plus 0.01 AY minus 0.04 AZ. And what is the P1? P1 position vector is 0.03 AX plus 0.08 AY plus 0.02 AZ. Step 2. So P1 value we got, P2 value we got. Step 2, calculate the distance between the two vectors. So how to calculate the two vector? Two vector calculate is the end point minus, if there is one point P1, this is the point P2. So we have to calculate the force at P2 from P1. So end point is P2, the starting point is P1. So we will calculate P2 R12 is equal to P2 minus P1. So what is the P2 minus P1? If we put the value, we will get the R12 value is like this. Next we will move to the step 3. Calculate the magnitude of the distance vector. What is the magnitude? Ax square plus ay square plus az square. So what is the magnitude we got? We got the magnitude of a square plus b square ay square plus 0.06 square. So we got the magnitude. Then we will calculate the unit vector. What is the value of the unit vector? Unit vector is equal to r by unit vector equals to r by r, the a by mod of a. Now we will apply the Coulomb's law. What is the Coulomb's law tells? Coulomb's law tells that, what is the Coulomb's law tell? F12 is equal to Q1 Q2 by 4 pi epsilon R12 square AR. And if we put all the value, we will get the value of is equal to 9 AR, and it is the unit is Newton. So this is our problem 1. Next we are moving to our problem 2. What is the problem 2? Determine the potential of a 004 meter caused by a total charge 10 to the power minus 8 Coulomb distributed uniformly of a disk of the radius 4 centimeter lying in the Z is equal to 0. At the center of origin. So we have to calculate the potential. What is the formula? The formula is the V is equal to rho V, means the volume charge density, by 2 epsilon A square plus H square to the power half minus H. So what is the value of A? A is the distance, and what distance we have taken? 004 meter, means A is equal to 4 meter. And what is the radius? Radius is also given as the 4 meter. A is equal to 4 meter, H is equal to 4 meter. So how to get the potential? First we have to calculate the rho V. Rho V is equal to Q by 4 pi R cube. So this is the volume charge is given 10 to the power minus 8. The rho V we can calculate. Epsilon value we know. So if we have, what is the value of epsilon? Epsilon is nothing but the 8.854 into 10 to the power minus 12. And if we put all the values, we can calculate the value of the potential. For equal charges of 20 microcoulomb in the free space at P1, P2, P3 and P4 are respectively. Find the net force Q5. Find the net force Q5 is 200 microcoulomb meter. So there are the three XYZ axis. So what are the steps? Similarly, write the position vector of 2 or 4. Here it is the 4-point charge. Calculate the distance vector with the Q5 to Q1, Q5 to Q2 like this. Calculate the magnitude of the distance vector. Calculate the step 4. Calculate the unit vector. And step 5 is the apply the Coulomb's law. So, if we calculate the force we can use the superposition theorem. We will use here superposition theorem. And according to the superposition theorem, F is equal to F1P plus F2P plus 3P plus 4P. How to calculate the F1P? Q1 by QP, P is nothing but the Q5 by 4 pi epsilon R1P square AR. Next we can calculate the F2P similarly with respect to the second point, F3P and F4P. So if we add these four forces, we can get the total force. This is known as the superposition theorem. Next we are moving to the problem 4. Calculate the electric field intensity at point P is equal to 0.02, 0.2 in the free space caused by a charge Q 5 nanocoulomb. So there is a free space due to this, and we have to, this is the charge, it creates a field somewhere. We have to calculate the intensity at the point P. So similarly the problem is again similar. Write down the positions vector of Q 0.2, 0.1, minus 2.5 and P 0.2, 0, minus 2.3. So we can put the value and we can calculate the distance vector. So this is the from Q to P. So it is the distance vector will be P minus Q, position vector of P minus position vector of Q, as the distance is Q to P. Calculate the magnitude of the distance vector. Next one is the calculate the unit vector. We know calculate the unit vector means if the distance is R, so it is R by mod R. Calculate the unit vector and apply the intensity. Apply the intensity E is equal to Q1 by 4 pi epsilon R square AR. And if we put the value, we will get 186.77 AX minus 46.7 AY minus 93.3 AZ. Next is the, actually this is problem number 5. The volume charge density of anything has been expressed by 10 z square x sin pi y. Calculate the total charge when x is equal to minus 1, 2, y is equal to 0, 3 and z is equal to 5, 6. So what is the volume charge density? We know that the charge density is 3 types: line charge density, surface charge density and volume charge density. What is the volume charge density? Volume charge density means the number of charges per unit volume. What is the volume charge density? Volume charge density means charge per unit volume. So what is the amount of the charge? dq is equal to total charge. What is the volume? Volume is always dx into dy into dz, because we are taking a rectangular time. We are taking a rectangular or Cartesian coordinate. So what is q? Q is nothing. What is the q? Q is nothing but the integration of rho v dv. So if we can write the rho v dv, what is the equation? Equation is 10 z square x sin pi y dx dy dz, and we will do the integration 3 times. What are the value? X is equal to minus 1 to 2, y is equal to 0 to 3, z is equal to 5 to 6. So if we do the integration, so x is equal to minus 1 to 2, y is equal to 0 to 3, and z is equal to 3 to 3.6. We are taking this value. X is equal to minus 1 to 2, y is equal to 0 to 3, and z is equal to 3 to 3.6, and the equation is 10z square x sin pi y dx dy dz. So what will be the integration? The integration will be 10z cube by 3 sin pi y by pi, and if we put the value, we will get the volume charge density. The total charge is the 62.57 coulombs. Next, we have a given field of E minus 6y by x square ax plus 6 by x ay plus 5az. Calculate the potential difference VAB when A is equal to minus 7 to 1 and B is equal to 4, 1, 2. Again, first we will discuss the step. What is the step 1? We know V is equal to minus E dl. V is equal to minus E dl. So what is the step 2? What is dl? So if it is we are taking again in the Cartesian coordinate, and dl is equal to dx ax plus dy ay plus dz az. So what is E? E is equal to minus E dl is equal to E dot dx ax plus dy ay plus dz az. What is E? E is nothing but the minus 6y by x square ax plus 6 by x ay plus 5az by z. So we are doing the dot product. We know that the ax dot ax is equal to 1, ay dot ay is equal to 1, az dot az is equal to 1. But if we do dot product crossly, ay dot ax is equal to 0, az dot ax is equal to 0, and ax dot ay is also 0. So we are just, if we do the multiplication, we will only get the ax dot ax, ay dot ay, az dot az. So if after multiplication we are getting minus 6y by x square dx plus 6 by x dy plus 5 by z dz a to b. So what is the integration? Integration for x is minus 7 to 4, 2 to 1, and 1 to 2. And minus means we can change the direction. And after solving this, we will get the value minus 6.04 volt. Problem 6. So the potential is given V is equal to 80 R to the power 0.6 volt. Assuming free space conditions, we will calculate E. The volume charge density at R is equal to 0.5 meter, and the total charge lying within the surface is 0.6. So first one we will get E is equal to minus grad V. What is the meaning of the grad V? E is equal to D by dr into 80, 0.6. We know what is the meaning of grad. Grad is nothing but the D by dr. So grad dot V is equal to D by dr 80 R to the power 0.6. So what is the value is coming here? 0.6 into 80. 1 minus 0.6 is nothing but the 0.4. R to the power 0.4. So this is minus 1. So R to the power minus 0.4 we can write 0.6 into 80 is 4.8. Sorry, 80 plus 48 by R to the power 0.4. And what is the unit? Volt per meter. Next is the calculate the volume charge density at R is equal to 0.4 meter. So we got the D. So what is the, we got only E and we know the V. We have to calculate the volume charge density. So first, if we know the E, we will calculate the value of D. What is D? D is equal to epsilon into E. Epsilon is nothing but the 8.854 into 10 to the power minus 12 into E. Now, if we use the Maxwell's first equation, what we will get? We will get rho V is equal to grad D. So, rho V is equal to grad D. So, what is the value of E we got? E value we got 48 divided by R to the power 0.4. So, what is D? D is equal to 48 epsilon R to the power minus 0.4. So, what is the value of the rho V? Again, rho V is equal to D by dr of capital D. So, it is the 48 into 0.4. 48 into 0.4 into what is the value of the D? One epsilon is there and R to the power minus 0 means R to the power minus 1.4. So, we will get the value of the, and what is the value of R? R value is given as 0.6. So, if we put the value, we will get the value of rho V. So, rho V value, or we can calculate like this, 1 by R square D by dr, R square dr. We can use any of the formula, no problem. So, what is the value of the last part? What is the total charge? Total charge C is equal to rho V into dV. So, it is equal to the total charge Q. So, what is the dV? We know the pi r cube. So, if we 4 by 3 pi r cube, if we put the value, we can get the total charge. Determine whether the potential of the field satisfies the Laplace equation or not. What is the Laplace equation? In the last class, we have discussed about the Laplace equation. And what is the Laplace equation? Grad square V is equal to 0. If this equation is proved, then we can tell this is a Laplace equation. So, we will do for the first equation. So, this is given x square plus y square plus z square. So, we can means del square x grad square. So, this is the del square x plus del here x square plus y square plus z square by del x plus del square x square plus y square plus z square del y square plus del square by del y square x square plus y square plus z square. So, what is the differentiation? Del by del x into 2x plus del by del y 2y plus del by del z 2z. So, all the z's are 0. So, x by x 2 plus 2 plus 2 is equal to 6 is not equal to 0. So, this field is not follow the Laplace equation. Next, we will move to the second problem. Second problem, again we will use the equation 1 by r, because this is in the r cos phi plus z. So here the variables are r, phi and z. So this is in a cylindrical coordinate system. It is in the cylindrical coordinate system, and in the cylindrical coordinate system we have three variables r, phi and z. So we can write 1 by r del by del r del b by del r plus 1 plus r square del square b del phi square plus del square b del z square. First we will calculate the del square b del z square. How to calculate? So this is the del by del z square into r cos phi plus z. So first one, if we do the one first time, del by del z by 1. So this is the constant. So this term we will get as the 0. Next we will move to our second one. What is the second one tells? The second one tells about the 1 by r square del square v by del phi square. So in the place of the v we will write r cos phi plus z. So z is a constant term, it will be 0. So it will be 1 by r square del square by del phi square of r cos phi. So first we are doing the one time. So if we do the one time, it will comes the r sin phi. Actually not r sin phi. Cos phi is equal to minus r sin phi. Again if we do this 1 minus 1 by r square del by del phi sin phi means again cos phi. So our second equation came as the minus 1 by r square. Sorry, 2 times r means r into r. Here 1 r again. Minus 1 by r cos phi we got. Then we will do the third one. What is the third one? Third one is about the 1 by r del by del r del v by del r. So we are getting 1 by r is coming out, del by del r, del b by del r means r cos phi. Again r is coming, so it is ultimately is coming r 1, so it is ultimately coming only cos phi. Here also we got the cos phi. So plus cos phi minus cos phi we are getting 0. As this is equals to 0, we will tell this is a follows the Laplacian equation. So this is my up to so in this class we have discussed some important problems, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.